Hello everyone. Let us discuss the pointer invalidation problem in shared memory in this video. So let's begin with what shared memory really is. Shared memory is one of the fastest inter-process communication mechanisms in an operating system. Instead of copying data between processes or using pipes or message queues, the operating system maps the same physical memory region into multiple virtual address spaces. Once the mapping is complete, processes communicate by directly reading and writing memory in the shared memory region. There are no repeated system calls and no copying overhead after the setup. I already have a full video explaining shared memory. If you have not watched that video yet, I recommend watching it first. When the operating system creates shared memory, it maps the same physical memory frame into multiple processes. However, the virtual address at which the memory appears does not need to be the same in every process. So consider, for example, this green region is the shared memory for process P1 and P2. And let's say this red block and blue block represent the same memory. Now, in the physical space, they will point to the same region, whereas in the virtual memory, they might have different addresses. The memory management unit is what translates virtual addresses into physical frames, and this translation happens entirely in the hardware. So shared memory guarantees that the underlying physical memory is the same, but it does not guarantee that the virtual address is the same. Let's go briefly over what a pointer really is as well. So a pointer is simply a number which is a virtual address inside a processor's address space. In this example, the pointer stores the value of 5000, which points to the region 5000 in process P1's address space. However, this might not point to the same 5000 region in the physical memory. Another process, say P2, might also have something at the address 5000 in its virtual memory, but might point to a different location in the physical memory. Now let us combine these two ideas. Shared memory allows both processes to see the same physical memory. Pointers, however, are virtual addresses meaningful only within one process. So this dangerous assumption naturally appears that if both processes share the same memory, we can safely store pointers inside that memory. This assumption feels logical because the data is shared, but it ignores the fact that pointers depend on the virtual address mappings and not the physical ones. So let us take a look at the failure more closely. Suppose we have a structure defined inside a memory called node, which stores some value and a pointer to other node. And process 1 here is the writer process, whereas process 2 is the reader process. So P1 is going to write data to the shared memory, while P2 is going to read from the shared memory. P1 writes the node object in the shared memory. That means it will also write the pointer value in the shared memory. But here comes the problem. The pointer value, which is 5000 in this case, only makes sense in case of the P1 address space. So if P2 tries to read this value of 5000, then it would refer to a completely different location or might not be mapped at all. So the result could be a segmentation fault, maybe an incorrect data access, or silent corruption. So it is especially dangerous because it may appear to work during testing if the memory layouts accidentally align. So this bug occurs because we confuse the abstraction layers. Pointers operate at the virtual address level, whereas shared memory operates at the physical memory level. So the MMU translates virtual addresses into physical memory during load and store instructions, but it does not reinterpret integer values in stored memory, right? That means it does not adjust the pointer value. So in our example, the pointer was written by process A and it stored a value of 5000. Now this value of 5000 only makes sense in case of the P1 address space. The MMU might translate this value to say 10,000 in the physical memory. Whereas if the process 2 tries to access the same memory of 5000 and pass it through MMU, then it might translate to say 20,000 in the physical memory. That means these addresses do not match and they might point to completely different data. The operating system intentionally guarantees identical physical memory while maintaining separate virtual address spaces for security and stability. Pointer invalidation is therefore not a flaw in shared memory, but it is a misunderstanding of how virtual memory abstraction works. So what can be the solution for this bug? One of the most easiest solution is to use the base address of the shared memory and pair it up with the offset of the memory address to access the real data. So basically, when accessing the next node, we compute the real address by adding the offset of the base address to the base address. As each process knows the base address of the shared memory, it is only sufficient to store the offset in the data structure. So to find the actual address, we can use this formula. So to summarize, the key idea to remember is really simple. Shared memory shares data, not address meaning. If a value depends on specific virtual address, it cannot be stored in shared memory without transformation. Whenever designing shared memory structures, always ask whether a field is process relative. If it is, redesign it using offsets or other abstractions. Understanding this distinction is what separates writing working programs from designing the correct systems. Thanks for watching.